Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed selected questions from competitive examination for IIT and medical. Up to question number 120 I have discussed. Now 121 onward today I will discuss. Now I am telling the question number 121. You keep a pen and paper with you so that you can also solve numericals. Most of the questions are based on numericals, 90%. And so now you should keep paper and pen with you. Now I am reading the question number 121. When 100 ml of 1m NaOH solution and 10 ml of 10 NH2SO4 solution are mixed together, the resulting solution will be: first, it is alkaline; second option, acidic; third option, strongly acidic; and fourth option, neutral. Now you have to answer, calculate it. Okay. What will be the answer? Again I am telling one more time question. When 100 ml of 1m NaOH solution and 10 ml of 10 NH2SO4 are mixed together, the resulting solution will be: first option alkaline, second option acidic, third option strongly acidic, fourth option neutral. Think and answer. It is based on N1 V1 is equal to N2 V2. That formula you have to use. Now just try to solve. You can solve it within 1 minute. Now I am telling you, explanation I am telling you. 100 ml of 1m NaOH means 100 ml of 1n NaOH means molarity you are converting to normality. But here in case of NaOH, normality and molarity both are equal. Both are equal. Means 100 ml 1m NaOH solution means 100 ml 1n. M is equal to N in this case, because NaOH, only one OH is there. Molecular weight divided by OH, number of OH, here only one is there. Hence M is equal to N. 100 ml 1m NaOH means 100 ml 1n NaOH. Now this 100 ml is mixed with 10n H2SO4. 10n H2SO4. Then now here already it is in a normality. Then NaOH is 100 ml. 100 ml N you have converted. Now 10 ml of 10n. 10 ml of 10n H2SO4 means what? 10 into 10. 100. 100n H2SO4. Correct? N1 V1 is equal to N2 V2. That concept you have to use. Then 10 ml of 10 NH2SO4 means 100 N H2SO4. 100 N H2SO4. Then now see, NOH is also 100 ml and now H2SO4 is also 100 and both are 1N 1N. Hence both will neutralize. Hence correct option will be neutral. Solution will become neutral. Option D. Next question I am telling you. The percentage of copper and oxygen in samples of CuO obtained by different methods were found to be the same. This illustrates the law of 4 option is there. First option, constant proportion. Second option, conservation of mass. Third option, multiple proportions. Fourth option, reciprocal proportions. Again I am repeating the question. Question number 122. The percentage of copper and oxygen in samples of CuO means cupric oxide obtained by different methods were found to be the same. This illustrates the law of first option, constant proportion. Second option, conservation of mass. Third option, multiple proportions. Fourth option, reciprocal proportions. This question is asked in AMU, okay, AMU examination, and previous question was asked in medical examination 121. Now this question 122 is also asked in AMU exam. Now tell me the correct answer. Its correct answer is a constant proportion. Okay, it is based on definition of law of constant proportion. Direct question, direct answer. Okay, constant proportion. Question was the percentage of copper and oxygen in the samples of CuO. Samples, okay, more than one. Samples of CuO obtained by different methods. All are CuO only, but different methods were found to be the same. This illustrates the law of constant proportion. Okay, correct answer is constant proportion. Question number 123. If 10 to the power 21 molecules are removed from 200 mg of CO2, then the number of moles of CO2 left are: first option 2.88 into 10 to the power minus 3. Second option 28.8 into 10 to the power minus 3. Third option 0.288 into 10 to the power minus 3. And last option is 1.66 into 10 to the power minus 2. Okay. Again I am repeating the question. If 10 to the power 21 molecules are removed from 200 mg milligram of CO2, then the number of molecules of CO2 left are: option 1 2.88 into 10 to the power minus 3. Second option is 28.8 into 10 to the power minus 3. Third option 2.88 into 10 to the power minus 3. Fourth option 1.66 into 10 to the power minus 2. This question is asked in IIT. Now solve it. Think. Question number it is 123. Think. Here I am telling you explanation. How will you solve? Here you can see 200 milligram CO2 is there. 200 milligram CO2 means how many moles? Then first 200 milligram you convert in gram. 200 divided by 1000 means 0.2 gram. 0.2 gram divided by 44. Then you will get mole because 44 is the molecular weight of CO2. Then 0.2 divided by 44 mole means after dividing you will get 0.00454 mole you will get after dividing. 0.00454 mole. Now mole you are knowing. Then you multiply it by Avogadro number. Then you will get a total number of molecule of CO2. Then from this or directly from mole is there, you calculated mole 0.00454 mole. Then 0.0454 mole you can write like this 4.54 into 10 to the power minus 3 mole. You can write same things 4.54 into 10 to the power minus 3 mole. Okay. And now from this 10 to the power, according to the question, 10 to the power 21 molecules of CO2 is removed. Then 10 to the power 21 molecules means how many mole? How many mole? 10 to the power 21 molecules of CO2 means now you convert in mole by dividing it by Avogadro number. 10 to the power 21 divided by Avogadro number means 6.02 into 10 to the power 23. Then you will get, after dividing, you will get 1.66 into 10 to the power minus 3 mole. See, 10 to the power 21 is upside, down is 23. Correct? Then down is 23, upside 21, then down will be 2. It will be 10, 21, 10, 21 cancelled. Means 10 to the power 2 will remain. And then 1 divided by 6.02 into 10 to the power 2. Then now that you can write, after solving it will come 1.66 into 10 to the power minus 3 mole. In terms of mole, you calculated 10 to the power 21 molecules means 1.66 into 10 to the power minus 3 mole. Then now this mole you have to remove from the 200 milligram, that is the mole you converted 4.54 into 10 to the power minus 3 mole. Then from this you remove, minus, do the minus, means 4.54 into 1.66, both are 10 to the power minus 3, that you keep it outside, common. Then 4.54 minus 1.66, it will come 2.88 into 10 to the power minus 3. Then this is the actually answer, 2.88 into 10 to the power minus 3. Hence correct answer is option A. Option A, 2.88 into 10 to the power minus 3. This question was asked in IIT. Now next question, 124. A compound contains 38.8% carbon, 16.0% hydrogen, and 45.2% nitrogen. The formula of the compound would be option 1 CH3NH2, option 2 CH3CN, option 3 C2H5CN, option 4 CH2NH2 whole 2. Again I am reading second time question. A compound contains 38.8% carbon, 16% hydrogen, mean H, 38.8% carbon, 16% H, and 45.2% N. The formula of the compound would be option 1 CH3NH2, option 2 CH3CN, option 3 C2H5CN, option 4 CH2NH2 whole 2. Think and answer. It will take hardly 1 minute time. Think. Actually, it is based on empirical formula. Then easily you can solve it. Carbon percentage is 38.8%. Hydrogen percentage is 16%. Nitrogen percentage is 40.2%. Then atomic weight of carbon 12. Hydrogen 1. Nitrogen 14. Then percentage atomic weight you will calculate 38.8 divided by 12, that is for carbon. And similarly for hydrogen 16 divided by 1. And similarly nitrogen 45.2 divided by 14. Then percentage atomic weight, it will come 3.23, 6 means 38.8 divided by 12, it will come 3.23. And for hydrogen it will come 16 divided by 1 means 16. And for nitrogen 45.2 divided by 14, it will come 3.23. Hence if you will simplify 3.23, 16 and 3.23, then you will get 1:5:1. This is the ratio, 1:5:1. Okay. Then now you got the ratio 1:5:1 means CH5N. CH5N, that is the empirical formula. CH3N. Correct? Then empirical formula you got CH3N. Correct? Its correct answer. Its correct answer will be option A. Option A. Its correct answer will be CH3NH2. CH3NH2. Okay. The formula of compound would be this CH3NH2. Empirical formula, now you calculated CH5N, then that you can arrange it as a CH3NH2, CH5N, that you can write CH3, 5 hydrogens are there, then that you can add CH3NH2, CH3NH2, then that is the option A, CH3NH2. Here see, very tricky question, means empirical formula you are calculating, but that is not given option answer. CH5N is not given option, but CH3NH2 is given. Then you can set it like that, CH3NH2. This question was asked in medical, CPMT. Okay. Now next question I am telling you, question number 125. What is the normality of 1m solution of H3PO4, phosphoric acid? What is the normality of 1m solution of H3PO4? First option is 0.5 n, 0.5 n. Second option 1n. Third option 2n. Fourth option 3n. This question is asked in AIMS exam. Now you think, quickly you can answer. Just to think. Its answer will be, its answer direct, even by seeing the question you can answer within 10 seconds. Question is asked in AIMS. Okay. Then what is the normality of 1m solution of H3PO4? Then its correct answer is 3n. Here H3PO4 is there. Then m is equal to 3n. M is equal to 3n. Okay, 1m H3PO4 means 3n H3PO4. 3n H3PO4, because equivalent weight is equal to molecular weight divided by 3. In this case, 3 replaceable hydrogen is there. Hence, you will get 3n. 1m means 3n H3PO4. Remember always formula, equivalent weight is equal to molecular weight divided by replaceable hydrogen or replaceable OH ion. And according to the question, if for acid, if for these things, for acidity, basicity, accordingly you divide sometimes by H. Okay, that is the basicity, acidity, OH. Then it is very easy. Within 10 seconds you can answer. And this question is asked in AIMS. Now, next question I am telling you. Question number 126. There are 3n, I told you, that is option D. Now question number 126. How much water should be added to 200 cc of semi-normal solution of NOH to make it exactly decinormal? Correct? It is also very easy question. This is asked in AFMC medical, AFMC examination. You can answer it very easily within 1 minute, less than 1 minute. Again I am reading the question. How much water should be added to 200 cc of semi-normal solution of NOH to make at exactly decinormal? Decinormal means n by 10. Option is given. First option is 200 cc, second option is 400 cc, third option is 800 cc, fourth option is 600 cc. One more time question I am reading. How much water should be added to 200 cc of semi-normal solution of NOH to make it exactly decinormal? First option is 200 cc, second option is 400 cc, third option is 800 cc, fourth option is 600 cc. This question is asked in AFMC exam. You can answer very quickly, with less than 1 minute. Think and answer. See here, it is easy. 200 cc, semi means n by 2. Semi means n by 2, then 200 cc of n by 2. Here you have to apply N1 V1 is equal to N2 V2 formula. Then 200 cc of N2 that is equal to VCC of N by 10. Correct? You can write 200 cc of N by 2, that is equal to VCC of N by 10. N1 V1 is equal to N2 V2 formula you have applied. Then V you have to calculate. N1 V1. Then first case, that is the N2. Semi means N2. Then N2 into 200 cc, that is equal to V unknown. You have to calculate how much volume. Then V, simply write V, and that is the dc. Dc means N by 10. Then V into N by 10 means 200. N1 V1 is equal to N2 V2. 200 into N by 2 is equal to V into N by 10. Then you can calculate easily value of V. Then V value will 1000, means total volume will be 1000 cc. Total 1000 cc. Then how much water you have to add? In 200. Already 200 is there. Then 1000 minus 200, 800 cc. Hence volume of water to be added. Already 200 solution was there, you wanted to make it 1000. And normality from the semi you wanted to convert into deci. Hence now V total volume you calculated 1000. Then from the 1000, 200 you minus it. Then 800 cc you have to add. 800 cc water you have to add in 200 cc solution. Then total will come 1000. And 1000. Hence correct answer will be 800 cc. Okay. Then option will be C option 126. Question number I was telling you. Then that option C is 800 cc. That is the correct. Now next question I am telling you. Question number 127. Number of molecules in 100 ml of each of O2, NH3 and CO2 at STPR. Again you listen. Number of molecules in 100 ml of each of O2, NH3 and CO2 at STPR. First option in the order CO2 is less than O2, O2 is less than NH3. Second option in the order NH3 is less than O2, O2 is less than CO2. Third option the same. Fourth option NH3 is equal to CO2 and CO2 is equal to less than O2. Again I am telling the option. Question again one more time I am reading. Number of molecules in 100 ml, you remember. Number of molecules in 100 ml of each of O2, NH3 and CO2 at STPR. Option 1 in the order CO2 is less than O2, O2 is less than NH3. Second option in the order NH3 is less than O2, O2 is less than CO2. Third option same. Fourth option NH3 is equal to CO2, CO2 is less than O2. Think, this question is asked in medical, BR medical, MADT. Think, you can answer within 1 minute. Just to think. See here, equal volume under similar condition contain equal number of molecules. Remember, equal volumes, 100 ml is common for all according to the question. Then equal volumes under similar condition contains equal number of molecules. Hence this answer will be option C, same, the same. Correct? Number of molecules in 100 ml of each of O2, NH3 and CO2 at STP are same. This question was asked in medical examination, Bihar medical, MADT. Now next question, question number 128, that the two samples of lead oxides were separately reduced to metallic lead by heating in a current of hydrogen. The weight of lead from one oxide was half the weight of lead obtained from the other oxide. The data illustrate. Option is given. First option, law of reciprocal proportions. Second, law of constant proportion. Third, law of multiple proportion. Fourth, law of equivalent proportion. This is also asked in examination, this question. Again, one more time I am reading. The two samples of lead oxide were separately reduced to metallic lead by heating in a current of hydrogen. The weight of lead from one oxide was half the weight of lead obtained from the other oxide. The data illustrate. First option, law of reciprocal proportions. Second, law of constant proportions. Third, law of multiple proportions. Fourth, law of equivalent proportions. This answer also you can tell directly within 30 seconds. Within 30 seconds, 10 seconds you can tell. By seeing you can tell. Now think. Its a correct option is a third option, that is a law of multiple proportion. Okay, this by the given option shows that the weight of lead combining with fixed weight of oxygen are in the ratio 1:2 divided by 1, or in other way 1:2. Correct, which is in accordance with the law of multiple proportion. 1:2, one is a 1:2, other is a 1. 1:2:1. That also you can write 1:2. Correct, you can write 1/2:1. You can write 1:2 also. Then which is in accordance with the law of multiple proportions. Now I am stopping only here. Next class again I will continue. Thank you.